Okay, guys, I just wanted to post another example here for section 6.3. So this example we're looking at here, we have another linear model on a scatter plot here. If we look at that scatter plot and zoom in for you, we see that this particular scatter plot is looking at some data about wooden roller coasters, and we're looking at the height of those roller coasters versus the length of those roller coasters on this side. Okay, so height versus length. And we can see that the relationship between height and length of these roller coasters has a close linear relationship. So that would have a high R value close to 1. And we have a linear model the computer has generated for us here, that blue dotted line, to estimate that linear relationship. And we just want to do a little bit more practice with understanding the difference between actual data points, what the linear model is estimating, and finding that error again. And we're also going to look at X and Y intercepts as another example in this example. Okay, so the first question I want to look at is using the linear model. So this means we're only focused on the line to estimate the length of a roller coaster that is 66 feet tall. Okay, and then we're going to answer the question about interpolation or extrapolation. So if we go to 66 feet, then we were looking on our scatter plot, right about here would be 66 feet, and that's the point on the line right there that I'm emphasizing, okay? Let me see if I can't get that to be a little bit more on the actual line. Sometimes it's a little hard to get it exact there. So the point on the line would be about right there, around 66. So if I think about where that line is estimating a roller coaster of 66 feet to be, I would look at the point right about there, which if we drag that back, is right about halfway through 2,000 and 2,500. So the line is estimating that a roller coaster of a height 66 feet. I would estimate that to be about 2,250 feet long. Okay, now we see that there's an actual data point though where we have 66 feet. So that is lower than our linear estimate is. So I would say that's only about halfway up. I'd go there with about the actual length of the roller coaster that we recorded that was 66 feet tall. That actual length was lower. It was more like probably 2,125 or 2,100, something like that. Okay, feet. So anytime where you have that error between the actual data point and the linear model, that's when you can calculate error. So let me erase these lines here. When I'm calculating error, I always, again, error is going to equal the estimate minus the actual. Okay, so my estimate from the linear model was 2,250. Again, this estimate means it's coming from the linear model. And my actual was 2,125. Now, again, your estimates from this graph, because we don't know, we're eyeballing this, could be a little bit different. So whatever you estimated from the linear model minus whatever you estimated from what that actual point was. Very certain though here that the actual was less than the estimate because that actual data point was below the line. Okay, so when we subtract those, I see that I overestimated my graph was overestimating, my model was overestimating that data point by 125 feet. And I know that's an overestimate again because my linear model was greater than my actual, which means my error is positive. So this was an overestimate. And I just realized we forgot to answer the second part of the question on part A, so let's do that really quick. So when we did all of this, were we doing interpolation or extrapolation? And we were doing, in this case, interpolation because we were looking at values in between the data points given, right? 66 was one of the data points, so we're doing interpolation when we're in between any of those data points. interpolation if we were looking at anything in that range. Okay? So if you do it again and you use your linear model, whoops, didn't mean to make that mark there. Use your linear model to estimate the length of a roller coaster that is 10 feet tall. Then you need to go to your height axis. And now we're going to go look at 10 feet tall. And we see here that we need to extend this line in order to look at 10 feet tall. That line is now going outside of the given data points. So here we are going to be doing extrapolation. Okay, anytime we're looking at extrapolation, we need to be careful of model breakdown. So as I'm looking at extending that line, it looks like 10 feet hits my model right there, and that estimates a length of 500 feet. So here I would give the answer 500 feet is the estimate for length, and I know from what we talked about before that that is extrapolation. I always check for model breakdown with extrapolation. Now this makes pretty good sense. If it's 10 feet tall, I could have a length of 500 feet. There's no negative height here. There's no really small height that wouldn't make sense. So we don't have any model breakdown there. The last thing I want to do is review what the x-intercepts and y-intercepts are. So remember, that's where we cross the x or y axis. So we're going to look to see where our line crosses the y axis or the x axis. So we again are going to extend that line and figure out where it crosses. So that's my estimate of that line being extended. And I can see that it crosses the x axis down here and crosses the y axis right about here. And we want to think about what those mean in this situation to understand if the model did break down at those intercepts, because we have extrapolated pretty far when we're moving that far outside of the data point. So the x-intercept here, pay attention to your scales. We're not going very far to the left, and one step here is 10. So I would say that's maybe around 2 or 3 for my x value, maybe 3, and y is always 0 for your x-intercept. So in this case, it would mean that a roller coaster with height, remember x-axis is height, with height 3 feet is 0 feet long. And in this case, we would have model breakdown at this point because we would never be looking at a roller coaster, first of all, that is 0 feet long, then the roller coaster doesn't exist and would not have a height. Okay, our y-intercept is just about as far up the y-axis, but that's going to be a higher number because our units, our scale here on the y-axis goes up 500. So I would say here the y-axis is crossing the y-axis around 100. And again, y-intercepts always have an x value of 0. So this would be a roller coaster, abbreviate there, with height 0, because this time x is 0, the height is 0 feet, and length 100 feet. And again, I would say we had model breakdown at this point because why would we be looking at a roller coaster with height 0 feet and it's still having a length? We would assume that that point should be around 0, 0 there. Okay, so that's a good review of kind of all the things we can do with linear models so far, using them to do interpolation and extrapolation, and also looking at those x and y intercepts. So hopefully that other example helps you, but always, as always, email me or get on our help sessions if you need any help with this section.